start your presentation. There we go. All right.
Everybody see my presentation?
Yep.
Awesome. All right, so welcome. This is a work in progress, and it's going to be mainly focused on implementation of DevSecOps practices in Salesforce. I'm not going to be covering a lot of information on what DevSecOps is. There is room for that in this presentation as it evolves, but right now it's mostly how we're applying those principles to Salesforce. And what I find interesting about this subject is I see like a meeting of two storms, if you will. Like you have these SaaS offerings such as Salesforce becoming more popular, and you have DevSecOps, which is also becoming more widely accepted within the community. So these two meeting, although it is much about Salesforce, it's also a lot about the future of how we're going to be doing work. So that's why I find this interesting and I find it exciting. Yeah, and that's it. So without further ado, I'll get started. If I can get my cursor in the right place. So what is Salesforce? We can't really start talking about how you apply DevSecOps principles unless you understand what Salesforce is and how it got to where it is now. So Salesforce was originally created in 1998 as a SaaS solution for CRM demands, and it has evolved into the market leader in sales and service, marketing, integration, and custom application development. One of the key features here with Salesforce is that they extract the infrastructure management away from the software development. So you're not maintaining databases or spinning up containers or managing service, at least within the applications, Salesforce application itself. And it started, at least the mantra throughout the 2000s was clicks, not codes, with focus on declarative development to build data models and UI features. And it's important to understand where Salesforce started, because you wouldn't be able to really understand what you're looking at, especially in a brownfield application, if you did not understand how some of this development was done initially. And so as the company has grown, the more demand on flexibility and customization also has grown. And so Salesforce really had two options: either adapt with the requests from its user base or really tighten down what it wanted to offer people. And they decided to expand what is available. And in doing so, I believe, helped drive down the risk of competition, but also made sure they weren't leaving money on the table with consumers that maybe would use the product, but not in its low code, no code state. This is a diagram that I really like. I pulled this from a book called Mastering Salesforce DevOps, which is kind of like the Accelerate book for DevOps, only for Salesforce. And you can see here that we start with on-prem, you're managing everything, and we kind of go up through the different services here: infrastructure as service, platform as service, and then finally software as service. And this is where Salesforce lies. And you'll see that, you're managing your data and your configuration. One thing I want to point out here, though, that this application is a bit of a gray box here. While you're not managing the core application of Salesforce itself, you are able to implement quite robust modifications to your org on top of it. And so it's a little bit of a gray area on what you manage of the application versus what Salesforce keeps to itself. So again, you have to understand the evolution of Salesforce to understand how it's gotten to the point that we can apply DevOps principles to it. And we began with declarative development. So when Salesforce started, it was all UI based. You created your data objects and relationships in the UI. You had custom logic tools to apply logic to those objects and relationships. Two of the most popular tools that most declarative developers would be familiar with is Process Builder. I have a little snippet here to the right, and you can see that any admin who wants to stretch their legs into applying some logic can go in here and they can kind of click through how data would flow and what action you would take on that data. And I would just point out that flows is similar in the concept. It's a bit more complex. You can work in some user interface into it, so you can accept user from the data from the user. But the big thing to take away here is that everything was done in the UI in Salesforce's tool set. And the way that development was done is through sandboxes. And a sandbox is a clone of your production org. And the only difference being how much of the data you would put in there from your production, if any, to run your tests. So in your sandbox org, as a copy of production, you would modify whatever you needed to modify, and you would put those modifications into a change set, and you would send it over to your production org. And it is all done in the UI. That's, I can say that a lot, but you get the picture here. It's clicks, not code. And so as time went on, Salesforce decided to offer Apex classes and triggers. And this is when they open it up and let you actually implement your own code into your organization. And they give you something called the developer console, which is sort of their version of an IDE, where you can go in there and you can browse the classes, you can make modifications, you can implement your own classes and triggers, and you can implement custom business logic here and increase your function and customized functionality. But the big thing here was that you were able to now put unit testing alongside your classes and triggers. Not only were you able to do it, they actually mandated that you had 75% code coverage. While most places would actually shoot for more than that, it's kind of interesting, because now you have, where before you were hiring declarative developers who maybe were, promoted admins, now you're bringing in programmatic developers who could do more, and they could add more layers to your Salesforce org. And of course, once you start doing that, then people start wanting to follow certain patterns. And one of those patterns would be DevSecOps. And you want to start implementing some enterprise patterns here. And so Salesforce introduced what's called Salesforce DX, or SFDX, and the SFDX CLI toolset. And what this toolset allows you to do is access the API. And this is what the Salesforce API, and this is what enables us to start taking a DevSecOps approach. We're able to detach development from our orgs now, because we can push and pull code via the API in the CLI toolset. And now we can put our code into version control. Another thing that we're able to do here is we're able to increase the organization of our classes. Before, if you were to pull down your code base from your organization, all your classes would be under a classes folder. You can kind of see that here in this example. You have this classes drop down, and you have a bunch of classes. And it's what people in the Salesforce biz like to call the happy soup. So now with SFDX being able to detach the development, we're able to actually organize this code into files, and we're actually able to make this more structured and more human readable, and we're able to increase our organization, and it helps with many developers working in the same space. Another thing that we're able to do is we're starting to be able to apply what is called unlocked packages to your org. Now, packages historically with Salesforce, they were always locked, and they were brought in through the marketplace. You had no control over these marketplace packages. You brought them into your organization, used the functionality as they were programmed. But now with unlocked packages, we're actually able to pull in packages that are managed by a community of developers. And this allows us to do a lot of unique things. It allows us to loosely couple our packages together. So now we don't have this giant monolith of Salesforce org. Now we can break it down. And we can do this through dependency injection. And there's some great packages out there. We have John Daniels on the line. He is one of the architects of some of these dependency injection packages. And what you're able to do then is you're able to inject a package and some of its logic level stuff like selectors and such into the core Salesforce. And I'm oversimplifying things here, but it's just helpful to know that that's how you're able to start pulling together all of these elements while keeping them separate in different repositories and whatnot. And then we're also able to automate deployment, again, through the CLI and the API. We're able to build a package in a pipeline, and then we're able to deploy that package to an environment. And it can all be automated if we want it to be. This is all very simplified, by the way. There are some complex issues in almost each one of these. And I'm going to kind of touch upon it, but I just want to give you an overview of where Salesforce is now with what it offers and what can be done. So what are your first steps? You're either approaching a Salesforce, if you're a DevOps environment, you're approaching Salesforce, you're either approaching it as a greenfield project or a brownfield. And there are different steps to both, but they all have similar approaches that you might have to untangle. The first thing to understand is the different personas that you'll be running into in a Salesforce project. And while users, admins, and product owners are all familiar, one thing I want to focus in on here is declarative developers and programmatic developers. And understanding that these two personas are going to have their own ramp up and spin up demands. A declarative developer coming from a Salesforce environment will understand Salesforce and how it works within itself, but will need to spin up on object-oriented thinking, on just programming in general, like understanding a language like Java, stuff like that, version control, developing in an environment such as VS Code. All of these tools, all of this knowledge will have to be brought into this declarative developer. But the advantage here is that the declarative developer knows Salesforce, so they will know the unique aspects of working within Salesforce. And there are a lot of success stories of declarative developers coming up and being really fantastic Salesforce developers. On the opposite end of the spectrum, we have programmatic developers who are maybe coming from a Java background, and they are not familiar with the Salesforce environment. They will have an advantage of knowing, hopefully, source or version control and the tool set and object-oriented thinking, but they're not going to understand immediately the restrictions on the Salesforce side. Because you do not control the database or any of the API, there are some restrictions like governor limits, for example, and it really enforces best practices. For example, like you can't put a SQL call query in a loop. Salesforce will yell at you. So it enforces some of those best practices that some programmatic developers can get lazy with. Then the other two roles here, systems architect and DevSecOps engineer, are two of the more important roles as you're trying to move into a DevSecOps space with Salesforce. The systems architect is almost more important because they're the people who have to understand how it all comes together. Because if you do not architect your program or your Salesforce org properly, you are never going to be able to implement DevSecOps. And for any DevSecOps engineer, you will understand that. But the system architect is important. Now, sometimes the systems architect will also be the DevSecOps engineer, because they understand how it all goes together. Then the natural extension would then to start implementing some Salesforce or some DevSecOps practices. The thing is, though, they might not have the knowledge that a DevSecOps engineer brings to the table, and that's what makes that role useful, because Salesforce is still very much evolving here in this space, and the more DevSecOps engineers that are engaging with Salesforce, the better the offerings will become, because DevSecOps, they understand how this stuff works, how deployment and continuous integration works. And that's where Salesforce wants to go. So it's important to have these people and not just make a systems architect the DevSecOps engineer. So that all said, now that you're architecting for DevSecOps, one of the key elements here is getting your team to shift to DevSecOps mind space. And there are a lot of great offerings, companies, blogs, people giving talks on introducing DevSecOps concepts. And just rattling a couple off the top of my head: the DevOps Handbook, the Unicorn Project, and Accelerator, all great resources, at least to read. But the idea is you want your team to understand everything from a DevOps perspective. And part of that is introducing new tooling to some people, such as version control. So getting people up to speed with Git and development environments like VS Code. These are things that you want to have in place. These are processes, and getting people up to speed with that and how to work with Salesforce in those environments, because it's a little unique than some other projects. Now, using unlocked packages is another consideration here. The reason why unlocked packages makes a Salesforce DevOps project really shine is because it allows you to break down parts of your org and allows you to separate implementations. The architect behind your Salesforce, either migration or development, will probably look at unlocked packaging, or you would want them to at least consider unlocked packaging when you're developing here, because it helps break down releases into smaller manageable chunks, and it helps people understand what you can deploy and what you can work on when you're doing your actual development. And you should determine what you want to keep kept in code. This is more of a question that people are going to ask and that you want to have an answer for. But the quick answer is you want everything in code. Everything that, because you want to be able to get away from the idea that you're copying down a production instance to a sandbox for development. And you want to be able to use these packages and deploy them to a blank slate and be able to do development and then blow them away. So you want to be able to keep not just your custom code in code, but also the metadata that goes along with your org. And so I just said scratch orgs. Well, what are those? So scratch orgs are blank slates that you're able to deploy your packages to. And the advantages they give you over, say, a sandbox is that they're lightweight, they have a short lifespan, and they really give you they give a developer separation when they're doing their development. Whereas if all of the developers are developing in one sandbox, you have possibly people stepping over each other. Or, did you check this in? Does this conflict with this? Does this conflict with that? Right when they're doing development, which is not ideal. With a scratch org, you're able to deploy your package. You're able to do your development on whatever package you need to develop on. And then you can blow that scratch org away. You can do your PR request, and you're off to the races. Okay. Scratch orgs is also important when you're in your pipeline process, because it is what enables you to stand up your environment that you're going to run your unit tests and maybe regression tests within. And so the fact that you can call them up, load your packages up in a pipeline is also critical to a DevOps CI/CD. And also the question, you're going to ask yourself before you even get here is, am I in greenfield development or am I in brownfield migration? Greenfield development, brownfield migration, you know, the problems are unique in Salesforce, but they rhyme with just about any other software project. Greenfield, you can make it the way you want it if you architect it the correct way. And brownfield is breaking up the pieces, seeing and trying not to break what you're trying to put together. You know what I mean? So yeah, that's it for architecting DevSecOps in a nutshell. So now that that was easy, right? Now that you've gotten everything set up and you're good to go, you know, now you can set up your CI, and there should be CI/CD pipeline. But you want to choose your tooling. You can use GitLab here. You can use Jenkins, etc. But basically what you're doing here is you're building a package. And one thing to note here is the package, you don't manage the Salesforce package, the binaries. They go into the Salesforce cloud, and you are giving a unique ID to access that package. So when you get to the deployment phase, you use that unique ID to deploy your package. But down here, I have an example, and you could see this is a fairly basic pipeline, but you know it's familiar. You have your SAS testing. You might have some custom testing like permission set testing here. Then you see you're creating your scratch org here, and you're running your tests, unit tests most likely. But if you're going to do something else on the back end before you blow it away, and then you create your package. So that's kind of the way it is. Now, one thing that's missing here is deployment. A lot of places will choose to deploy that in another step, or will hand this package to another team that handles deployment. But you could have a continuous deployment here if you wanted. So that's it for my presentation. I wanted to put a couple useful links and book recommendations here at the end. It's a smattering of material, all with mostly this assumes that you understand Salesforce and that you're ready to move into DX territory. This is not introductory to Salesforce material, but it is helpful when you're starting to get into the more deep dive of what you need to do to start breaking down your program or Salesforce org and start getting yourself ready to do DevOps. So with that, I felt like I sped through that because I talk a lot faster when I'm on camera, but here's my mandatory Dilbert strip. I think I might use this at the end of all my talks because this is my favorite. So any questions, any comments? I am trying to groom this so I can give it at a conference. So any opinions there would also be nice.
So my first question is, what's the, I mean, I followed along. Here's all the things that I would need to do, and there's ways to do the CI and to do unit testing and all that. But what's likely the biggest thing I'm going to run into, the biggest surprise I'm going to have when I say, okay, I've been a Java developer. I know how to do CI/CD there. I'm going to do something here. I'm going to use Apex. It looks Java-ish enough, so I can get into it. I write something, and then I go to do something. I'm going to be surprised because you can't do that in Salesforce, or you can't do that in SFDX. Is there one or two things that are the big surprises there?
Yeah, so I'm still learning what those surprises are, frankly. but there are, like I mentioned, one of the big ones is governor limits and hitting restrictions on what you can call back from Salesforce itself. But the way that there's not like a ton of options out there for how you manage unlocked packages yet, because it's still very early on. So you really have to understand the few ways to do dependency injection. There's only a couple that I'm aware of, and so that to me was the biggest hurdle, is understanding, okay, I have to do this, it goes here, understanding that way of working within Salesforce. But Salesforce itself, it's rather flexible if you understand Java. I wouldn't say you're going to have a huge effort in transitioning. I wouldn't say that you're gonna be like, oh, this is horrible. You might, some people might, but you know, I wouldn't say it's years in the making. Like most people will pick it up fairly quickly. Now, John Daniels, who is on this call, has been working in this space for a long time, and he might have a better answer than I do as far as that goes. But yeah, I don't think anybody is going to regret their decision on working on a Salesforce project coming from a Java world.
So I guess you said that it does enforce like some of the best practices, and well, I know, you know, some people are pretty good and aggressive about putting linters and, you know, running find bugs and that type of thing on their software. I guess if you're not used to any of that static analysis feedback, you're not used to writing unit tests, not used to having to write, you know, some enforced code coverage limit, all that might seem draconian, you know, for some developers. I know there's been certainly places we've gone that, you know, that would have been completely unheard of to try to enforce those things.
Well, that's fair. I mean, personally, I like the unit testing thing. Like, I don't understand why it's such a controversy to write unit tests for your codes. I never understood that, and I will never understand that. So I don't, you know what I mean? Like we've all been on DevSecOps projects where there is no testing, and half the job is getting people to write tests, and not only actively but retroactively, you know. So you know, Salesforce, in my opinion, makes it easier for a DevSecOps engineer because the unit tests have to be written. Now, for a developer, yeah, you're going to have to write unit tests. Sorry.
Mm-hmm.
So
to follow up,
I have a question.
Sorry, Glenn. To follow up on that, what does Salesforce do in terms of code quality checks? And you know, traditionally in your build systems, you also have those. So what would you still put in those build systems to do code quality checks, or any kind of quality checks in the process?
Well, so the unit testing, right, is just as good as the unit test it's written. You know what I mean? You can easily spoof a unit test, right? And
well, I'm not trying to get past the controls. I just want to understand where the controls should live in a process that includes like a GitLab or a Jenkins.
Yeah. So if you're doing like static tests, you can do that on the code before you deploy it to an org, you know. You know, after it's deployed to an org and you have an address that you can have something like Selenium go do testing, you can do that too. That is kind of what people aren't doing quite yet that I've seen, is that there is not much regression testing done. You know what I mean? There's a lot of unit testing, and there can be some static testing out there, but you know, regression testing is still one of those things where there's a lot of room for room to grow there in the Salesforce development community, in my opinion.
So I mean, Salesforce, when they made the Apex runtime engine, they laid down this blanket code coverage requirement that thou shall have 75% code coverage before you're allowed to go into production. But that is the only physical constraint that they have for general programmatic code. When you also factor in the idea that Salesforce salesmen are running around saying it's a low-code alternative, and therefore you don't need to run unit tests if you use the low-code alternatives, and they try to make that a selling point, but the reality is, especially for this group, it's sort of like, why in God's name would you create an enterprise system with no unit tests, without any kind of some kind of quality check? There are other things, Tom, like you alluded to, you can create all kinds of checks and static checks in the pipeline, And typically that's where people do put them. There's nothing specifically inherent on the platform, but you know, things like PMD and other tools are the big tools for things like static code analysis and checks like that in the community. So
Great, thank you.
yeah.
So I have a question. What was, I forget what it was called, but you were talking about like the unrestricted packages, or what are they called?
Unlocked packages.
Unlocked packages. So with the recent uptick in, well, I don't know if it's recent uptick, but people are focusing on supply chain attacks right now. Is there any sort of a tool like Claire for Docker or, you know, Sonatype Nexus for these packages?
I do not know the answer to that question, John.
So in Salesforce, all of their packages, their artifact repository is in-house. And so we don't have any kind of direct access to it. Whenever any package is created around the world, it is stored in the great Salesforce database in the sky. So, but it serves the role and function as some level of a Sonatype repository or artifact repository.
So they do scanning of the packages for malicious content?
They scan packages that are destined for their app exchange, their marketplace listing. But for you can create packages that are for, you know, one-off bespoke development for a client and not be required to go through those types of security testing. So
But even beyond that, you're beholden to as good as they are at scanning, right? There's nothing else you can do really for it.
I mean, you can do again, whatever you want to put into your own private pipeline is definitely value add there. But I mean, there's nothing once the artifact is created, then, you know, that's pretty much housed in their environment. So, I mean, at the end of the day, it's not at the end of the day, packages are not, you know, a physical jar file. It's more a series of database records, because under the hood, everything in Salesforce is nothing but a database record. And so it's just it's the logical concept of a package being applied to a specific org. And so that's the way they maintain it and manage that. Yeah. I mean, going back to your earlier comment, Gene, about what coming from a Java developer, what would I not see in Salesforce, or what would I be shocked by? And things like generics are not in Salesforce. You know, and it's nearly impossible to have a singleton pattern implemented in Salesforce, just due to the constraints of what's going on. But, you know, it's just getting used to the nuances and the peculiarities. I mean, you know, my own personal story, I was working as a Java consultant, and I was on a project that took over 3 months for the client to actually physically stand up a development server for my project. So I was running everything off of my laptop. And at the same time, a friend told me about Salesforce, and I went to developersalesforce.com and filled in the, you know, 12 question form. And 30 seconds later, I got an email saying, here's your fully configured development environment. And I was like, all right, I'm done. I never looked back. So that was 11 years ago. So, yeah.
So in the, I guess the hierarchy of Linux distributions, you're more of an Ubuntu fan, not a Gen 2 fan.
Yes, very much so.
Says the Gen 2 fan.
Uh,
Do you ever switch?
I actually went to Ubuntu. I just didn't have the time to merge all the packages anymore.
Yeah.
Every once in a while, if there's something that I have to do that's bleeding edge and has to pull from the latest of the Git repository, then I'll spool up a VM and see if it's worth it. But yeah, daily driver is Ubuntu and Chromebook. And then unfortunately I have to use Windows, but we don't talk about that.
So I will say
you were a Windows master, Glenn. Wasn't it you who was just saying that Windows was the best thing in the world?
I have a
sounds like
saying. I have a saying. Windows never fails to fail me. I mean, it's consistent in that regard.
Comes from the man who on Twitter is at AzureLover.
Yes.
Oh heck no. Yeah, there would be a problem with that at work. I don't think that would fly.
Brian, when we were saying about the, would surprise some people having to do the unit test, you don't understand why people don't. We've been places where trying to convince people that source control was a good idea took some fights.
I know I am fortunate not to have dealt with some of these more exciting clients, let's say.
Yeah. But I mean, one comment actually I did notice when you were going through some of the stuff is things like that you were saying you were targeting DevSecOps, DevOps practitioners with this. You made a comment about convincing people to use something like Git, that would be a little bit of a fight. And that might be worth explaining that is actually a,
you think I should embellish a little bit more?
Well, just explain why, like,
yeah.
Because I know, I mean, I've given talks where I've pointed that out, that places that don't do like unit testing, right? People like, half the room is, how is unit testing controversial? It's like, well, because you've never worked in a federal contract where, they're still just moving off of CVS onto SVN, now.
Well, and this time they'll get it right, Gene. And
this time. We know we messed up last time, but this time, we're going to use Git just like it's supposed to, just, with our unique flavor, because we're Snowflake.
It'd be nice to have if not like a demo, but some kind of example, something that gives me more a flavor for what you're talking about in context of Salesforce.
Yeah, it's something that I didn't have it finished for this. So I wanted to get it down to an hour, right? And so I want to work more DevOps concepts in it. I want a demo, and I want this. So I need to like refine the pluses to this presentation. But what I want to do is I want to set up like a demo org where I can like show people, okay, this is what your package structure might look like, and this is how you would pull and work with the pull and push and work with the CLI and whatnot. But I need to think about it a little bit more, because I don't want to have a demo that just starts to go off and never has a conclusion. You know what I mean? So I like to have something wrapped up. So that's definitely a work in progress.
Well, another comment along those lines, John mentioned that everything's basically it's basically a database that you're accessing, right? That Salesforce is basically a database, and that mentioning that, it looked like I was looking at some code samples on the side while you were talking about, what does Apex look like and that, and I couldn't really tell whether it was database or forms or what, but every framework we use in just about any language is tied to, it's either a front end to a database, it's a front end to a web page, it's a front end to a form. They almost always tie it somehow like that, and that might be a good way to set the context for people like me that aren't familiar at all with Salesforce, that it's front end to a database.
Yeah, I just naturally assume people knew that Salesforce is a front end to a database, but
I mean,
yeah, you're right.
I know it is, but
that should be said.
Thinking it through.
Yeah.
It's an interesting scenario, working in Apex, especially. Obviously Salesforce is what it is, but it's a very homogeneous architecture, and there's a single, there are obviously there's no infrastructure decisions. The decision about the database has already been planned and everything. The decision about the app server, all these questions have been abstracted out. And so, there's some interesting perks, I guess. I mean, things like making the querying language a first tier artifact inside the language itself. Some of the shortcuts and the things that they've been able to do to make the language a little bit more appealing from that perspective. It's kind of, there are definitely some interesting perks there. They've been introducing a lot of the core concepts that we see in other languages, things like async messaging architecture, that type of thing. That's been a recent development in the past 5 years. And, they keep working to start to get it right. They still get some things still need a lot of work. And
Yeah, it should be noted that there are some things that just don't work yet that they're working on. And so it's not a perfect platform. There are pain points that people have to work around.
Yeah. And I mean, and one of the pain points is, because it's a single homogeneous environment, you are at their mercy as far as dealing with bugs. I mean, they've created an incredibly complex scenario under the hood, and when the bugs really get deep in there, it takes, you're fighting not only to get them to even focus on the bug, much less fix it, but they do massive amounts of regression testing for each of the 3 triennial releases that they make, and they're constantly releasing patches. But those patch builds, the amount of regression testing and automated regression testing that's underway every week for any kind of patch release to the pods is just staggering what's going on there. And it still is, just the amount of testing. It's not a matter of what you're supposed to be testing, it's what you're not testing. And they're continuing to find out more of that. But, I mean, if they have an outage, they had an outage 2 years ago, and it was somebody on the DNS server admins ran a script, thought he was running it against test, ended up running it against prod, and wiped out half the DNS servers that are running all of the various pods. So half of the world of Salesforce came to a screeching halt for about 8 hours. And, businesses, it was just absolutely just pandemonium and chaos around the world and all these affected instances. And so, you live with that. You live with the ups and downs. You don't have too much in the way of infrastructure maintenance or server maintenance or anything like that. But when you're going to go down, you're going to go down very hard and very spectacularly. So
when you say they're releasing patches a lot, would you say like the language itself or the interfaces, is it a fast moving environment? Is it, gradual? Is it you're constantly learning new things, or they're just constantly cleaning things up?
When you say fast moving, what do you mean in context?
I don't know. I mean, just, you work on, I guess if you're work used to working on like Spring, right? Java Spring, that those things, it changes relatively frequently, but the Spring you learned 6 months ago, a year ago, 2 years ago is still going to be valid. If you're used to working on, React or JavaScript frameworks, the JavaScript you worked on last week was hopelessly outdated this week because, they've replaced the framework completely.
It's more the former, especially at the Apex level and programmatic level. That is really relatively stable. There's not a lot of churn there. They bring out new features periodically, but their original UI that they used through the 2000s was more akin to what you would find in ASP or JSP or something like that. That kind of page-based model. They moved away to what they call Lightning. The Lightning UI. It replaced the classic UI, and the Lightning UI is more. It's gone through 2 iterations now, and the second iteration is more akin to Angular and that type of React.js, those types of frameworks, and it's closer to that model. So
it's slow. The Lightning UI is slow. It is slow.
The original UI, yes, the original Lightning UI. The newer one, the Lightning Web Component, WebSocket, that type of thing, it's better. It's still not, that great. Having said that, it's new. It's learning to balance the nuances in the browser on the DOM. Make sure you're not getting something really stupid as far as creating the DOM. And the other part of it is, how much traffic, how much noise do you have back and forth to the server is going to kill your performance. So all the same rules apply. It's just a matter of figuring out where to go apply them.
And how about backwards compatibility? You said they run 3 trains at the same time. Is that so?
So they
Good.
do 3 major releases every year. It's the spring, the winter, spring, and summer releases, and so they will. The winter 22 release will be gearing up for early October, and they have pretty much coded everything that they're going to put into it now, and they are just hammering it right now. But again, it's disruptive around those 3 release dates. They say that they've released to the sandbox environments, to the testing environments, a copy or a beta copy of those new operating systems, and so you're working on those. But there's always things that are hiding in the weeds, and you never find them until production day. So, but again, it's what it's going to be. So.
Should be noted though that some things like the CLI you can run different versions of, right, John?
Yeah. The CLI is as you said, it's a relatively new concept. When Salesforce started 20 years ago, it was an online CRM. There was no way to extend it. And, some of the things that they started doing in, say, 2012, 2013, 2014 was looking at the developer experiences holistically. And one of the things they noticed in comparing to other languages is other languages tend to have a CLI. And so they started running some experiments, and eventually they realized that the CLI concept was going to work. And Heroku had already perfected a lot of their CLI. They had built their CLI off of what they eventually released as the Oak Cliff framework. And so Salesforce just brought those developers over and created the Salesforce DX CLI. And it's represents one of a unification of the tooling standards that they've had. Prior to that, there were a lot of different tooling vendors going off on their own, building similar features, and so it was sort of a Wild West as far as the tooling was concerned. Different vendors had different features supported where others had others, and so it was very disparate as far as what tooling options were available. And but now they've sort of gotten their act together, and they're heading in the right direction with this new approach. But yeah, they're with the CLI, since it's a desktop-based app, they've been releasing updates to that almost weekly for the better part of 3 years now, and that's been helpful as well. So, but they get a lot of things right, they get a lot of things wrong.
So the different ways that you can make applications on Salesforce, does that drastically change the way you would put them into a DevSecOps pipeline?
The different ways you make applications on Salesforce, that drastically changes the way you put it in the pipeline?
Yeah, how are your decisions in terms of how they gear what you do in different points of your pipeline?
Yeah, well, not really, in my opinion. So you're basically just making the package. You know what I mean? Like, there are different ways of making the package for Salesforce, but at the end of the day, you're still grabbing your stuff from the repository, doing whatever you're doing before you release it to a scratch org, which you don't control. So you're spinning that up in Salesforce. So you're not necessarily spinning your own container to put your package into. You're actually creating a container over in Salesforce world. So you don't have to worry about spinning up a container. And then so in that way, you have less infrastructure to manage, and it's more like making a call to the CLI to do this.
Yeah.
Spin up this, deploy this. You know what I mean? Run this, tear this down. Does that make sense? Does that kind of answer your question?
I think so, yeah.
Yeah, Tom, to give you a little example, we have most of the Salesforce projects over here are running off of a single Jenkins instance. And Jenkins is not doing much heavy lifting at all, except executing a couple of commands from the CLI. And really, it's a relatively small, it's like a, what is it? Gene, it's a E4, whatever it is. the SedCiv AWS instance is a number 4. It's very small, small AWS instance, because you don't really need a lot of grunt, because it's basically just calling and making API calls over to Salesforce and telling them what to do. That's our CI pipeline. Your other question, I think that there are 2 major decisions that are made on a project that will drastically change what you're able to do in DevOps arena, and that is, are you working in a greenfield or a brownfield? And the second is, are you utilizing the packaging or the DX and the packaging approach, or are you going to what is called in the community more of the classic approach? The classic approach was no type of artifact management, atomic artifact, or atomically versioned artifacts at all. So no concept of a jar file. It's all of the metadata, all of the code piecemeal, and deploy. Most of the people would deploy from one environment to another, just the deltas. So just keeping track of all of that becomes somewhat of a nightmare, especially in enterprise class environments. And so, I mean, if you get into that, if you get into a brownfield and no packaging approach, your DevSecOps really will be, you really can't even automate it. Most of the time, they end up having trained monkeys, trained monkeys to sit in a seat and extract code from one environment. They put it into a source control because they want to have a backup medium, but that's about it. It's not serving as a change management medium. And they'll push it to another open, and they'll hold their breath when they push it into the other environment and hope to God that they got it right. I had a contract with CarMax one time, and I was watching them live in this old arena, this classic arena, and we moved a bunch of their teams over to DX and packaging, and it was like night and day what they were able to do and achieve, and what they were able to automate and going forward. And the projects that we're doing here at Steampunk, a lot of the Salesforce projects right out of the gate, we've been setting them up in DX and packaging and deploying, telling our clients and educating our clients that this is the way we're going to be doing it for it. And once they get educated about what's really possible, because again, this DX and packaging is still very new in the community. Once they see it happen after that first release, they've been sold, and it really makes our competitors look bad now, because they've got to get on board to keep up with us. So
yeah, and there's also the concept of a dev hub too that you are building. So you will probably explain that a lot better than I am, but basically you're building your scratch orgs off of this dev hub.
Yeah, I mean, at the end of the day, every environment in Salesforce is an instance of an org somewhere. And so at the end of the day, if it's the production org, well, they know the billing information. Salesforce knows the billing information for that production org. They know who they're going to send the bill to. Sandbox environments are these test environments that are replicas of the production environment, and they are logically attached to the production network. So Salesforce understands who to send the bill to for these environments. With the scratch orgs by default are blank orgs that are disconnected from any environment. They're not affiliated with any environment. So, and they're created from the command line. They're created from the CLI. And so what happens, Salesforce needed a way to understand who to send the bill to. And so what happens is when you work in an environment with DX scratch orgs, you have to authenticate your CLI against some production instance, which is euphemistically called the Dev Hub. And so once you're authenticated against the Dev Hub, then you're able to spin up scratch orgs on behalf of that Dev Hub, and then they can send the bill to. The other aspect is the concept of ownership of these packages in the artifact repository in Salesforce. Again, they have to understand who owns these artifacts and who do we build, who has jurisdiction, who has ownership of these. And so they associate the artifacts, the packages with the Dev Hub as far as an ownership question. So that's what Dev Hub is really about.
Yeah, but it does play a part in DevOps.
So. It plays a part to, again, if you're not authenticated to the Dev Hub, you can't create a package that's a package version that's owned by regardless of whether or not you have the CLI. And so,
Given the complexity of Salesforce now, how long does it take you to spin up a new developer?
Like a scratch org?
No, a new person.
Oh, a new
it depends on what you want that person to do. There's a lot of different types of developers in the Salesforce community. There are declarative developers who've never had any engineering background, who have gone to Salesforce's Trailhead, studied a couple things on the weekend, and come out and they apply for a job. And because the demand is so crazy, they get the job. Then you got folks like Bryan who have got great background in other languages and can apply so much more of an engineering discipline, and he understands the engineering concepts. And he can latch onto the deeper thoughts and deeper trends of the developer, of being a developer in Salesforce. Again, it's like anything. It takes a while to. It's pretty quick to learn the vocabulary of the language, and it takes a long while to understand really the nuances of the language. And that's just as true here as any place else. I like developers like Bryan because a lot of the developer mindset is already trained him, and I can just teach him the vocabulary of Apex, and he's effective right out of the gate. But if I get a developer who's been in Salesforce for 10 years, never seen any other language beyond that, and mostly into the low code road, and was a history major in college, I'm having to teach all kinds of thought process to them. And I'm like, yes, Git is spelled G-I-T, not G-E-T. It's just all these little things.
Hey, to be fair, I was a non-CS major in college.
Well, but still.
So hold on, I wanted to take a chance to say thank you very much for the talk. I apologize, I have to leave a little bit early. I learned a lot more about how the Salesforce code gets in there, and definitely gave me some stuff to think about. So thank you very much, and take care, everybody. I'll see you guys in the next talk.
See you, Glenn.
Yeah, it's getting kind of late for me as well. I've got to sign off too, but Bryan, you did good. And Gene, thank you for having me.
Yeah,
well,
thanks
thank
for
you.
everybody coming and asking questions.
Absolutely.
But I do have one. Does anybody have any thoughts that, do I have to drastically change my direction if I want to get this into a conference?
I think the stuff that Tom was saying, some sort of demo, just to ground it, because I probably have used Salesforce or seen Salesforce. Well, I know I have at times, but I've seen reports and stuff out of it, but I don't know that I've ever played around with it. So I don't know, whatever the Salesforce equivalent of a hello world type thing, something simple that might kind of just ground it better, right?
Yeah, maybe just
especially because
how you deploy something.
Yeah, well, you picked a very, I think, made a good approach of, I'm going to talk to DevSecOps people about Salesforce rather than the other way around.
Yeah, so
which obviously is going to resonate better with me because I don't know Salesforce. But because of that, remember that you do need to explain some of the Salesforce stuff, I think. But other than that, I mean, I was able to follow along. I was, like I said, I pulled up a couple other links while you were talking about some of the Apex stuff to see what it looked like and that. And most of the comments I would have had were things that you got to on the next slide or so. Yeah, no, I thought it went well.
Cool.
Yeah, can we stop the recording?
Yeah, hang on just a second. Let me get it.